Here's a GRE algebra problem. Let's take a look. A rectangular game board is composed of identical squares arranged in a rectangular array of R rows and R plus 1 columns. The R rows are numbered from 1 through R, and the R plus 1 columns are numbered from 1 through R plus 1. If R is greater than 10, which of the following represents the number of squares on the board that are neither in the 4th row nor the 7th column? A lot going on here. So let me just point out that we have a variable in the question, right, R, and variables in the answer options, R, right? And when that's the case, when you have a variable in the question and then you have variables in the answer options, you should absolutely just pick a number for that variable, right? We're going to pick a number for R, and we'll solve the problem, and whichever answer option matches the answer that we get in the problem, that's going to be the winner. So what do we want to pick for R? Well, R does have to be greater than 10. So let's just say that R equals 11, okay? We'll say that R equals 11, and I'm quickly just going to sketch out the situation that I have here, which is that I have a bunch of columns, column, boom, 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 and I have a bunch of rows going across like this. Okay, well, I know that there are 11, the number of rows is 11, so let me just write that in here. Here's the first row, here's the second row, here's the third row, fourth, and on and on and on and on, all the way down to 11. And then here's, as far as columns go, I have R plus 1 columns. That's what the problem tells me. So R is 11, R plus 1 is going to equal 12. So 1, 2, 3, 4, 5, 6, 7, and I'll say ... all the way out to 12. Okay, now comes the fun part of the problem. We want to know the total number of squares on the board that are not in the 4th row nor the 7th column. Well, first things first, how many squares are there on the board overall? Well, there are 11 rows. I'll write 11 there, right? And there are 12 columns. So 11 times 12 is a total of 132. There are 132 cells or squares on this game board. And we want to know how many are not in column 4 or in column 7. How many are not in the 4th row, right? Row 4, or the 7th column. So in other words, I want to take out these ones, and I want to take out these ones all the way down, right? Well, in the 4th row, how many cells are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So it's going to be 132 minus 12. Keep tabs on this. And that gets me down to 120. And then in the 7th column, there are how many rows? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 cells going down here. So I'll subtract 11, and that gets me to, what is that? 109, right? So I'm at 109. But here's the thing. In subtracting out these 12 cells right here, and then subtracting out these ones, I double subtracted one of them, the one where they cross, right? So that one needs to be added back in because I subtracted it twice. So I'm going to add 1 back into 109, and that gets me 110. Okay, so 110 is the number of cells in this particular example that are neither in row 4 nor column 7. How does this relate to the answer options? Well, let's take what we picked for R. Remember, we said R was 11 and plug it in here. R squared is 121 minus 11. Yeah, that's 110. That works. Let's double check the other ones. R squared is 121 minus 1, 120, no. R squared is 121, no. R squared 121 plus 1, no. R squared plus 11, no, right? So the correct answer here is A. For more GRE tips and tricks or to sign up for my online course, follow the link on my profile.